Okay. In this session, we'll discuss the coverage topic. Okay, coverage is one of the most important topic in the system verilog. Okay, and also advanced topic, whatever the coverage or assertions, these are advanced topics in the system verilog. We'll discuss in depth of coverage, how to write the coverage program, how to check each test case, how to analyze in terms of coverage, and how to generate a coverage report for different simulators. Okay, we'll see all the things today. Today we'll discuss mostly the topics of coverage. Tomorrow we'll discuss on practical way how we will do the coverage. Okay, for different examples in a project level. Okay, so what is mean by coverage? Did you have any idea? Quality, quality in the sense, what is mean by quality? How much it is covering? Okay, how much it is covering means what it will cover. All available variables. Okay, inputs, outputs. Okay, okay. From girls, any idea what is mean by coverage?
No, ma'am.
No idea. Okay, see, coverage is nothing but whatever the Pawan Kumar said. It is the okay, it is checking how much we have covered the functionality wise or toggling wise, whatever the variables we have taken. Okay, if you take a memory has a different variables, right? It has a address, it has a data, it has a pointer, or if you take FIFO, it has a pointer, and it has a clock signal, reset signals, and different types of signals we will have if you take any type of example. Okay, and how much design code has been exercised. Okay, that is also correct. Okay, so if you take any project level, if you take IP level, or if you consider SOC level, we'll see so many variables which are dependent one by one. Okay, if you take a address, it will depend on the reset signal and also clock signal. If you take the data, it will depend on the address, clock, reset. Okay, so whatever we are writing the functionality, suppose we are writing some functionality for a particular block, small block. Okay, to check whether the particular data, all scenario of data, whatever we assign to the particular address, it is assigning correctly or not. Okay, 100% we are reaching our functionality or not, that is what we need to check. Okay, suppose we are taking data as a 32-bit variable. Suppose data we are considering as a 32-bit. 32-bit means each 0 to 1, or 1 to 2, or 2 to 3, or 3 to 10. Okay, every bit has some functionality. Okay, suppose you are storing some data in 0 to 1, or some other particular data you are storing in 1 to 2. Okay, or you are splitting your data into some parts, and each part you need to store some functionality. Okay, so in that case we need to check every part, whether we are covering every functionality or not according to your given spec. Okay, we will get one specification from the design engineers or verification engineer. From that spec, by using that specification, we need to check whether we are covering all the things, all the functionality or there or not. Okay, so that is nothing but the coverage. Okay, so in the coverage we have mainly two types. One is code coverage, one is the functionality coverage. So what is the code coverage and what is the functional coverage? Code coverage means it is mainly done by the design engineers. Okay, design engineers in the sense they will write so many blocks. right? They will write some expressions or a multiplexer block or some counters block or some registers block or some for loops or if else loop. Okay, so by using the code coverage, the design engineers check whether each block is executing its functionality or not. Okay, that is the code coverage. Coming to the functional coverage, as we are the verification engineers, we will done the functional coverage. Nothing but verification. Whatever we are writing the test cases for the verification, whether all the test cases is whether all the test cases is meeting its functionality or not. Okay, here we have taken only 32-bit data. If you take SOC level, we will find like this hundred thousands of signals we will see here there. Okay, in SOC level, if you consider thousands of signals, we will see like this data. Okay, so each signal whether it is covering or not. Okay, if it cover, then only we can tell our functionality is correct. At the end of the point, at the end of the project, how you will tell our project is done, our project is working correctly, 100% it is working correctly, how you will tell? Based on the coverage. Okay, we will have some coverage bins for each test. Suppose there is a test, how, what is mean by test case? First of all, we need to observe that thing. What is mean by test case? Suppose this is a SOC level. Try to understand. This is the SOC level. Okay. In SOC level, we have various types of blocks. Okay. Suppose here we have one memory block. Here we have one processor block or some graphic processor block or some north bridge IO or south bridge IO is there. Some other blocks will be there. For example, I am telling top level, but internally there will be lot of things. Okay. Suppose I want to verify this memory to the processor. Okay, so to verifying particular signal of the memory and particular signal of the processor, I will write one test case. I will write one related test case. Okay, what is there in the test case? In the test case, there will be test functionality. What is mean by test functionality? Nothing but the signal what the functionality it is doing. This signal what the functionality is doing. What is happening in between two signals? What we tell? What we need to analyze? Suppose if suppose there is a address or a data. Okay, if you take simple format, what is the address and data functionality? The data should be stored into the address. Okay, these two functionalities, the data should store into the address. So by using that, we need to write the test case. Okay, within the test case, we will develop the code related to its functionality. So for this test case, we need to analyze the coverage. Okay, in the test case, there will be so much functionality. Uh, there will be so many variables. Okay, so we need to check whether the each variable is covering the functionality or not by using the coverage. Already the variable has the functionality. Already we have done, it is test is passing. Okay, you need to check, if you want to analyze the coverage, you need to check whether test is passing or not first of all. Okay, are you getting my point? I think you are totally new for this. That's why I'm just trying to tell easy way. Okay. See, we have developed one test case. Okay. So we need to pass the test case. What is mean by pass and fail? Suppose this functionality between this variable and this variable, the functionality is passing, that means the functionality is working, then the test case will be pass, otherwise the test case will be fail. Okay, if test case fail means what happen? As a verification engineer, we have to try to pass the test case. Okay, how can we pass the test case? By doing debugging. Okay, debugging in that sense, fixing the errors. Okay, so Once the test case passed, then we can analyze the coverage for that particular test case. Okay, suppose this test case has 100 number of variables. What are those 100 number of variables means? For example, take one protocol, whatever the protocol you know, APB protocol. In APB protocol, we have address, clock, reset, uh, write, read signal, and strobe signal, protect signal, peace level error signal. All these will be there. All each signal has some functionality, right? So we need to check. Already the test is passed. In the coverage point of view, whether each variable is doing its functionality properly or not. That thing we will hit in the coverage. Already it is doing. Test passed means already it is doing. Those things we need to check with the help of coverage. Okay, did you got the point everyone? Once the coverage reached, that means every project main goal is coverage should be 100%. You take any project IP level or SOC level, the coverage should be 100%, must be 100%. Then only we can tell the functionality of the block is verifying, total functionality is correct. If you got coverage 99% also, the our project is not done. Okay, so that one point, that one bin also, not one bin in terms of 1,000 bins or 2,000 bins nearly it will have. So those bins also we need to cover. That is the main coverage. Once it reach 100% means total functionality is working correctly. If it left at least one bin means some functionality is missing. Otherwise, if you are, see, another one thing, okay, one bin is missing. Okay, your your test cases all are passing, or even your test cases are passed, but still some bins are left. Okay, then we need to exceed that bin. Okay, if you exceed that bin, then our coverage will reach to 100%. Okay, so those things we need to observe. Did you understood what is meant by coverage, everyone? Did you understood what is meant by coverage, girls? This is very important topic. If you don't understand, please let me know. We can discuss once again. Exceeding of bin, how will be done? Um, just there will be options. Okay, after generating the coverage report, we will see the database, right? Every company has their own database names. Okay, so there will be options there to exceed, so like that we can exceed. Last time I have shown you, right, the comment, these the test cases are passed, but these bins are not to be hitted. Like that, we will comment, will tell us wave off. We'll see the steps how the coverage will be done. Okay, if you see the block diagram here, right side, in Questa or EDA, how can we check the coverage? We'll discuss all the things. Okay, in Questa, in EDA playground, every simulator we have different coverage options. Okay, by using the coverage options, we can run the script. Okay, those things we'll see. Okay, see here right side block diagram, coverage driven verification. Okay, suppose here from verification plan, there is a verification plan. If you take a small block, for this block there will be related nearly 100 number of test cases. We will develop 100 number of test cases, or nearly 60 70 number of test cases, suppose. Okay, because every functionality we will check through the test case only, right? So that's why we'll create some test cases. For these test cases, each test case has some functionality, right? Each test case have to do some functionality, have to um, satisfy some things. Suppose you are sending the data from memory to processor. Okay, internally there will be so many things. So that signal need to satisfy that functionality. Okay, that operation, whatever. So whatever the code we are writing here regarding that, suppose if you take a small, we'll discuss in the small things. Suppose there is a register. Okay, register means how we will write a design code for parallel input parallel output register, or serial input serial output register, or any finite state mission. Those are designs, right? For that particular design, we will write some test bench, right? Like that, whatever the test cases we are creating, for each test case we need to write some functionality to verify particular design. Okay, so after writing the test bench, we will write the coverage code also. Coverage code is separate in the systemware log, right? So in that coverage code we will see different types of bins. Okay, so what I am trying to tell here, from verification plan, there will be test cases. Inside the test cases we will write the coverage, and within the coverage there will be all the things. Then see here, create initial coverage matrix. We will create the coverage for each test case. Okay, generate random test. We will generate some test cases. Okay, run the test, collect coverage. Run the test, collect the coverage means we already developed the test case, we are running the test case. Okay, if test is pass, then we can send to the coverage. If test is fail, for failed test cases we cannot observe the coverage, right? Because the functionality will not met. So we need to pass this coverage by fixing the errors. So once pass, collect coverage. Collect coverage means we will add some options to the that particular test, and then we will run some script file for the coverage. Okay, we'll run some script and upload to the database. So in the database we will check whether the bins are hit or not. Okay, so coverage goals met. Coverage goals met means, yes means the bins are, all bins are hitted, otherwise no. If not hitted means, again we need to identify the coverage holes. Coverage holes in the sense, whatever not hitted bins are there, we need to identify what coverage bins are not hitted. Okay, according to that coverage bins, whatever not hitted, we need to analyze by using which test case, by using which test case we can hit those bins. Did you understood the point? Okay, suppose a bin is there, address, some mem, cov. Okay, if you want to hit this particular bin, which test case we need to run? We have hundreds of test cases, thousands of test cases. Okay, so whatever leftover bins are there, we need to analyze by running those, by running which test cases we can hit the bins. Okay, so suppose if hitted means verification completed, and if not, identify the coverage holes, add test to target holes. Okay, suppose whatever the test cases we have, we are not able to hit the particular bins. Even we are trying with our test cases, but we are not able to hit all the bins. Then we need to target some test cases, we need to bring up the test cases, we need to add some new test cases related to the functionality to hit the coverage bins. Sometimes like that also will happen. Okay, so add test to target holes, enhance simulator generator, enhance coverage metrics if needed. Okay, so our main aim is to get the coverage 100%. Okay, to reach the 100% coverage, we can do anything. We can bring up the test cases, we can add the new features to the test cases, because our functionality need to satisfy. Okay, if 100% not coverage is not working means we are missing some functionality in our project. If we miss the functionality, there is no use, right? So that's why the coverage is very important. Did you understood everyone up to here? Clear? See here, uh, you have asked like how can we run the coverage. Okay, suppose if you are using any tool, suppose if you are using VCS tool or Questa Sim, if you use the VCS tool, this is the compilation run command. Okay, these options we need to pass while you are uploading the coverage. How we identify the coverage holes? How we identify the coverage hole means we will get the database. I will show you. Okay, I will show you. We'll get the database. Okay, see. This is the compilation command for the VCS. Like that NC sim, these are the options. Like that Questa sim, these are the options. Okay, so to generate only functional coverage, okay, see, after running the above program, the coverage report will show like what is the variable name, particular variable name, what we are taking, how much expected coverage and how much we have covered, and what is the percentage, 37.50, right? So still that point we have covered only 37.50. By days going on, we need to reach 100%. Okay, that is the main goal of the coverage. Okay, in the report, the coverage percentage is calculated by the covered or expected. Okay, so this is how we can check the coverage report by running the coverage script. Like that we are using EDA playground, right? So in EDA playground also we have different tools. Aldeck tool we are using, Questa sim we are using, Synopsys we are using, Cadence we are using. So for each tool we have the run commands. We need to add the run.do file. For each one we have the run commands. Okay, without run command we cannot generate the coverage report. Okay, so coming to the our topic. So you got the clarity, everyone, right? What is meant by coverage overall? Did you understood what is meant by code coverage and functional coverage? Code coverage not needed. Those are design engineers' duty. Our aim is mainly functional coverage. Okay. Have any doubts? Okay. Here the what is the code coverage and functional coverage? You can go through the theory part. And coming to the main how to write the coding for the coverage. Okay, cover group. First thing is cover group. What is mean by cover group? Okay, a cover group is nothing but, what suppose if you take a module, what is the need of module, end module? Within the module, end module, we will declare all the variables and we will write the functionality, right? Like the cover group is same like a module. Okay, within the cover group, end cover group, we will write all the things. Okay, we will create the cover points, we will create the bins, all the things will be written in the cover group. Okay, so if you see a set of coverage points, cross coverage, and optional arguments, formal arguments, coverage options, all the things will be sampled, whatever we have written in the coverage group. Okay, so if you see the syntax wise how we are writing, a cover group is defined between keywords cover group and uncover group. Okay, so this is what cover group, name CG and cover group. Okay, that we are creating here, and we need to run that thing. Okay, sample. What is mean by sample? Whatever we have created the cover group, that we need to do sample. Okay, nothing but at the rate of passage clock. Suppose if you trigger it with respect to the clock, with respect to the events, like that. Okay, and come into the what is mean by sample. By using the sample method only, we can run the code. We can run the coverage. Okay, cover group, CG and cover group. For CG, we have created the instance and initial begin cg.instance sample method. It is a predefined method. We need to use only sample. Then only the coverage will be run. Okay. And cover points, cover points is nothing but it is like a variable or expression, we can call it is a name, user defined name. By using the cover points we will create the bins. Okay, see, suppose example here, program main bit 0 down to 2y, bit 0 down to 2 values q, we are taking 3 comma 5 comma 6, 3 comma 5 comma 6. Cover group CG, cover point, we are taking some cover point, this is the user defined name, in that cover point is y. Okay, these whatever we have taken the bit here, that is the cover point y. And cg instance equal to new, we are calling that cover group, so that we are creating the instance for the cover group. So for each values of I, value I, y equal to values of I, cg inst dot sample. By using that sample method we will call the it will run the coverage. Okay, next topic is coverage bins. Main important thing is coverage bins. Okay, coverage bin is nothing but whatever we are taking the values. Okay, by using the variables we are setting some size, right? So for each size, whether it is meeting the functionality or not, just we are creating some bins. Okay, and by using the bins we are checking the each variable using the bin. Okay, if you see the theory wise, a coverage point bin associated name and a count with the set of values or a sequence of value transitions. If the bin designates a set of value, the count is incremented and the cover point matches to the one of the value in the set. If the bin designates a sequence of value transitions, the count is incremented every point. Okay, theory thing is little bit confusion. See, what mainly what is the bin means? Suppose we are creating some bin 1 down to 0. Actual data size is 32-bit size. Okay, in this 32-bit size, whether 1 down to 0 or 3 down to 4 or something, whatever the size we are taking, is it matching, is it working functionality or not? By using the bins we will split those data variable data. Okay, splitting is nothing but by using the bin we are taking that. Okay, so see here, implicit bins. What is mean by implicit bin here? Implicit bin is nothing but if you see the program main bit 0 down to 2y, bit 0 down to 2 values dollar whatever before we have taken. By using the inline coverage in implicit bins, by using the implicit bin, if you see the cover point y, cg cover group cg cover point y, cover point y, we have kept this option. What is that option? Option dot auto bin max equal to 4. Okay, by using that option we are telling that implicit bin, okay, within the cover point. Okay, so cg, we have created one instance for the cg, new of initial for each values of I, values of I is nothing but dollar. Okay, whatever we have taken, y equal to values of I, cg inst dot sample method. As we discussed, we need to call this method. Okay, sample method. So I want to check the coverage here. Total, actually how many are there? 0 down to 2. 0 down to 2 means how much? 3. Total 3 bits, right? Total 3 bits means 2 power 8. Okay, total 8 number of bins should have. Okay, those 8 number of bits, how many bins we have divided? We have divided into 4 bins. Okay, total 8 we have divided into 4. So each bin have two bits. Okay, each bin should cover two bits. Okay, 0 down to 1, 2 down to 3, 4 down to 5, 6 down to 7. This is bin 1, this is bin 2, this is bin 3, this is bin 4. You can take like this, okay, bin 1, bin 2, bin 3, bin 4, or directly you can put the size here, how many bins should create. Okay, like this it will create the bin. Okay, after coverage, what you will check, what it will check, whether it is covered or not. 0 to 1, is it covered here? No. 2 down to 3. 2 down to 3 is covered here. Any one of the bit cover also, no problem. No need to cover both. Okay. 4 down to 5. 4 down to 5 covered here. Yes. 6 down to 7. 6 down to 7 covered here. Yes. One bin is not covered. Okay. So we need to cover this thing in our test case. If you see in SOC level or IP level, this particular bin is not covering. Okay, so we'll check the coverage report now. How we will understand? Suppose here small thing means we are just telling theoretically, but how the coverage report will generate, we'll see. See here, run dot do option. Run dot do option, these are the options here to generate the report, coverage report. These can be taken by in Google. Okay, in Google also it will be available. You can check in that, otherwise I will share to you. Okay, so I'm doing run. Before run, see, there are different simulators in EDA. EDA is very good for coverage. Okay, we are using Aldeck. If you want to use Cadence, these run commands will be different. If you want to use Questra, these run commands will be different. If you want to use Synopsys, run command will be different. Okay, and if you see here, I'm selecting the option here, use run.do TCL file. Okay, if you do, this is a scripting, TCL scripting. Okay, we have scripting language, Perl, TCL, Python, like that, right? So here we have used the TCL. Okay, so use run.do file. Otherwise, if you don't select this option, it won't generate. So I have selected that option and generating. Okay, see here, from first onwards, report info. Okay, coverage report cov.txt was generated successfully. Exe cat cov.txt, those are run dot options, whatever we have given the run dot options, those things. Okay, cov.txt is the name of the coverage report. And report information, we will get the report information here. What is the user, runner, host, tool, and report file, all the things you can see. Input file, what is that, number of tests, number of tests is 1 here. Okay, what is the test is nothing but these values. Okay, whatever we have given the functionality. So number of test 1, and the test details. Okay, status is okay. Okay, and the seed is 1. Design hierarchy, how the design hierarchy, coverage type, weight, hits. Hits means how many it hitted. Okay, coverage group, coverage, weight 1, 75.0% hitted. How it is telling 75.0? Can anyone? How many, how it is telling 75.0? 3 by 4. 3 by 4, total 100%, right? In this 100%, we divided 100% into 4. That means 4 bins we have taken. In that 4 bins, only 3 bins are hitted. 3 bins means only 75%. Remaining 25% left over. Okay, so our coverage report is not hitted 100%. So how can you do not hitted 100% means? We will just recheck Okay, this is another code. Okay, whatever it may be. So how we will check if it is not reach 100%? We need to include the functionality. Okay, so suppose this code only I want to take. Okay, according to our code, it is 75%. As we see the bins are not hitted, it is 75%. Okay, if you check here, coverage group coverage. Okay, cover group number of hits 75%, goal or at least. So our main goal is 100%, right? What is the status? Status is uncovered. Status is uncovered, right? So here if you observe, it is not showing which bin is not hitted. It's not showing which bin is not hitted. Then how can we know if it not show? We need to know which bin is not hitted, right? Then we can analyze and we can hit accordingly. So if it not hitted, what can we do? Means we need to add a option here. Option dot per instance. Remember this one, per instance equal to 1, as Ramani asked, right? How can we know the whole is nothing but not hitted? Okay, so we need to check what are the covered bins, what are the uncovered bins. So if you see here, by adding this option in seventh line, we got which one is not covered. Okay, so what are the whole is nothing but which is a 0. Okay, 1 means it hitted, bins are hitted. Okay, so bin auto 0 down to 1 is not hitted, 0, it is not covered. Okay, 2 down to 3 covered, 4 down to 5 covered, 6 down to 7, all are covered. Okay, so this is the coverage report. Did you understood everyone? Did you understood? Suppose in this simple program, how can we hit 100% coverage? Just I am making here as a 1 here. Okay, after 1 running, now we'll say 100% coverage. See here, 100% coverage. All are covered, covered, covered. Okay, like this in the SOC level project, whatever you are taking according to our test cases, whatever the bins there are, there it is not this much of simple. There will be lakhs of bins. Okay, nearly thousands of bins will be there. So that will be the process for everywhere. This is the process. Did you understood everyone? Is it clear
Yes, ma'am.
how we will write the explicit bins? Okay, if you see here, previously implicit bin. Implicit means by using the option. But here we are taking explicit bin. Program main bit 0 down to 2y. Same program, but we are creating the bins here. Bin A, bin B, bin C, bin D. So what will be the coverage here? Can you tell? What will be the coverage here? Coverage result. Same example. Previously, what we did by using the option. Here we have used the option here. Option dot auto bin max equal to 4. That means total size we have divided into 4 bins. Okay. But like here, whatever we have written, actually we will write like this only, mostly. Okay. So we have divided into 4 bins here, bin A, bin B, bin C, bin D, without using that option. Okay, here also 75%, because whatever the size here for 3 bit size means 2 power 3, 8 number of bits it will generate. In that we have divided into 4 bins. So we need to check the coverage. Okay, we'll check now. and we will put that option also here, um, where you can put means after within the cover group you can put anywhere. Okay, what is that option? Dot per instance equal to 1. Okay, see what are not covered here. We have not used 0 or 1. If you use 0 or 1, you will get the cover. Okay, suppose in this place I am taking only into 3 bins. Okay, suppose bin 1 comma 0 comma 2, and bins b equal to 3, 4, 5, bins c equal to remaining 3 bins I have divided. So 6 comma 7. So what will be the output? I think here the 3 bit is missing. Okay, see, if you observe, this is the main thing you need to observe. What is the coverage report we got? 66.666. Okay, you need to take 3 bins. Within the 3 bins, 2 covered. 100% by 2. Okay, sorry, here 3, total 3, right? So 3 by 2. Like that you need to mention. If you see, bin A, 0 bins are hitted. 0 means what? 0 means what? Here either 1 or here either 0 or 1 or 2, anything not hitting. Okay, so that's why 0. And bin B, 3 comma 4 comma 5, total how many hitting? 3 comma 5, 2 bins are hitting. 2 2 hits. That is the main thing you need to observe. Okay, 2 hits. Bin C, 1 hit. Covered, it is covered either 1 or 2, or it is covered. Tomorrow I will show you how the exact project. Okay, tomorrow I will show you my project, then you will get to understand. Okay, so bin C, only 1 hit covered. Even it is 1 hit or 2 hit or 3 hits or 10 hits or 1000 hit, whether it is hit or not, that is important. Okay, if you take the SOC level, when you are writing the lakhs of bins, there the hit count will be 10,000 hits, 12,000 hits, 1000 hits, sometimes 5 hits, like that. Okay, even whether it is a low count or high count, that should hit. If it is high count means it will be advantage. Why? Because more number of variables, more number of scenarios are covering by using a single bin, by using the single bin. Okay, so this is how we can analyze the coverage report. Did you understood, everyone? Suppose I am taking here 6 comma 8 comma 10, 15, like this. Total how much size we can take? 15 means 3 bit size I am taking. Here also 3 bit size I am taking. um Bin A I am telling 1 2 3, this one 4 5 6, here 7 8 9 10. Bins D 11 12 13 14 15. Okay, total 4 bins we have divided. So in that 4 bins, so how many bins will hit, how many bins will not hit? See, we'll get 100% coverage. See, we got 100% coverage, but how many bins, how many hits we got for each bin, that we need to observe. For first bin, only one hit because only three is covering. For second, 4, 5, 6 is covering. 3, 4, 3, 5, 6 is covering. So three hits we got. For C bin, only two hits. From D bin, only one hit. But all are covered, hits also important. Okay, so I think you understand. So in this session we will see mainly what are the different types of bins we have. Yesterday we have seen implicit bins and explicit bins. Two types we have seen, right? What is mean by implicit bin? What is mean by implicit bin in coverage bins?
When we are not specified, then
Mm.
implicit be created, ma'am.
Yes. So whenever we are taking, suppose implicit bin is nothing but suppose yesterday what we have seen in our example, we want to functionality is 356. This is a small case, but if we go to practical level, there will be actual functionality. Okay. So 356 is there in our functionality. So we need to check whether these are created or not, sorry, these are covered or not by using the bins. Okay, actually what is the size we have taken? We have taken 0 to 2 bit, that means total 3 bit size. In that 3 bit size, we are suppose by using the implicit bin means within the cover group, by using the cover point, within the cover point we are telling option dot auto bin max, option dot, those are cover options, okay, coverage options. So we are telling auto bin max equal to 4. Okay, that means this bin total 3 bits, those 3 bits will be divided into 4 bins. 3 bits means 2 power 3, total 8 number of combinations. Those 8 number of combinations will create as a 4 bins. Okay, by using those 4 bins we are uh, checking these whether it is covered or not. All these 8 bits are covered or not, but 8 bits are not covered in our functionality. So we need to refunctional, that means reprogram again, okay, to cover the 100%, to get the 100% coverage. We have to modify our functionality. Okay, so for that purpose what we did yesterday, just we added it 1 or 0, right? So that it will get the 100% coverage. Okay, like that, this is the implicit bin. If you use within the cover point, if you use options, that is implicit bins. Explicit bins means what? Suppose there is a cover group, here there is a cover group, within that we have cover point, name of the cover point you take any name. Why? So explicit bin is nothing but here we are creating the bins. Suppose this cover point bins, bin A, because four bins, whatever you can take any number of bins. Yesterday we have seen, right? Like taking with the three bins, taking with the four bins. Okay, how many bins you want to cover all those cases? You can take those many multiple bins. Okay, you can take eight number of bits also, because eight number of bits are there. So you can divide into 8 number of bins and you can check the coverage. Okay, these all are like our designer written. Okay, whatever our usage or comfortable, we can write any type. Okay, explicit or implicit, or there are different wildcard bins, ignore bins, illegal bins, whatever we can take according to our functionality. What are the main things we want to cover? Okay, to hit the 100% coverage, how can we hit the 100% coverage? That is the main motive. For that purpose you can create the bins as your wish. Okay, so here we have created the four bins. Within the four bins we are telling this bin 0 to 1 should cover, this bin 2 to 3 should cover, this bin 4 to 5, this bin 6 to 7, like that. Total 8 bits we are covering. Okay, we are created the bins. If the bins hitted to the functionality, it will show the 100% coverage. Otherwise, the coverage will be decreased. Accordingly, we need to improve the coverage. Okay, up to this, you got the clarity, everyone, right?
Yes, ma'am.
Okay, next topic is transition bins. Okay, like explicit bins and implicit bins, we have the transition bins. Okay, suppose transition bin is nothing but a value is transaction is done from 1 to 2, 2 to 3, 3 to 4. Like that, is this transaction happening in this order or not? You can check. Okay, otherwise you want to only generate the odd values. Okay, whether this odd transaction is happening or not, you can check like that. Okay, otherwise you want to check repeating of three values three times, repeating of three times, like that. Ordering, these all are ordering. Okay, transactions, you can create the bins accordingly and you can check the coverage. Okay, so mainly here we are checking the transitions. Okay, so in the transition bin, we have different types of transitions, like a single value transition. Single value means 1, 2, 3, 4, 5, or otherwise 3, 4, 7, like that, whatever. Sequence of transitions. Okay, you need to give the some sequence, like 1 after 3, or 3 two times, like that. Set of transitions, multiple times. Consecutive repetitions, range of repetition, go to repetition, non-consecutive repetition. Okay, these are different type of transitions we have. So we'll write for each one. What we'll write example for each transition and we'll see. And what is the wildcard bin, what is the ignore bin, illegal bin, all the things we'll see. Okay, so first one is transition bin. What is the first transition bin? Single value sequence. What is the single value sequence? Nothing but, suppose yesterday we have written this for implicit bin and explicit bin, right? Just bin we need to change. I am changing just bin. Suppose here I am taking values 3, 5, 6 in the queue. Okay, within the cover point I am writing a two bins or three bins. Suppose bin, I want to take the transition from 3 to 4 and 5 to 6. I want to check the transition. Suppose I'm checking with the 3 to 4 equal to, this is the symbol. If you see 3 equal to right shift. So that is the symbol for checking the transition. Next, bins trans sum equal to, tran is showing in blue color. Okay, trans. I want to check 5 to 6. So what will be the coverage here? What will be the coverage here? Means we'll take another one also. Trans equal to 6 to 7. Okay. So what will be the coverage here? What is there in our functionality and what we are trying to cover? 3, 5, 6. Right? Can you answer? 100% coverage. Why 100% coverage? 3 by 3. Okay. 3 by 3. Are we covering here 3 to 4 transaction? Is it happening? 5 to 6. Is it happening? 6 to 7. Is it happening? One number is enough. Okay. One number. No. That is different. Here we are transition bin. Transition bin in the sense we are checking the transition. How many transitions are happening here? 1 by 3. Only 1 by 3. So what is the percentage of the coverage? 33.33. Okay, is that correct? We'll see. 33.33, right? So remaining, we are expecting 100%, but here getting 33.33. Okay, so yesterday what we told, like to show which are uncovered, we need to show which are covered and which are uncovered, right? So for that, which option can be used within the coverage group, not within the cover points? Okay, see, bins 3 down to 4 is 0, and second bin transaction is 1, which is a 5 to 6, and bins third one is 6 to 7. We are not covering 6 to 7 here. So that also 0. Okay, so how can we make this functionality? How can we make this functionality? 100%. So we can add here 3 to 4, comma 5 to 6, comma 7. Then you can make it as a 100%. Okay, as we are just learning here, it is very easy to add the numbers, but in the practical way, we cannot just add the number. We need to add the original functionality, what the functionality will meet to that coverage. Okay, so this is how we can cover the remaining bins, 100% bins. Okay, so this is the single value transaction. Single value transaction. What is next one? Sequence of transitions. Sequence of transition is nothing but we will take some order. Okay, suppose uh, here 3 to 4 is there, 4 to 5 I need to cover. Here 5 to 6 is there, 6 to 7. That means multiple values we are trying to cover with the bins, 6 to 7, and also 7 to 8. So what will be the percentage now? 66.66, because here if you see the value, only 5 are there, so 3 to 4 to 5 is covering, 5 to 6 to 7 is covering, 6 to 7 to 8 is not covering. Okay, now we'll do the run.
Ma'am, what is transition means actually? Like moving from one value to other value. What
Yes,
exactly?
see what transition we see, whatever we are taking within the values here, 3 to 4, 4 to 5, 5 to 6. If you take okay, I have taken here in a linear manner. Suppose if I take random wise 3, after I want to generate only odd numbers. Okay, or I want to generate only multiples of 3, 3, 6, 9, 12, within your range. 12 will exceed your range, right? Okay, 12, 15. Then I am changing this 0 down to 4, and also here 0 down to 3, total 15. So what you will cover according to your functionality, we will create multiple bins. Okay, not only our functionality, we will create the multiple bins, right? So every bin have to hit to the functionality. So we will write the bin accordingly. So here 3 to 6 to 12, 9. I'm telling 9. So how many bins will hit here?
One.
One bin. So one means 3 bins we have taken. 1 by 3. Some 33.33% we will get. Okay. We try to get remaining bins also have to hit. Okay. So remaining bins have to hit means here bins we have took wrong. Actually, functionality is correct here. Suppose you are taking functionality is correct, but whatever the bins we are taking, those are not correct to the functionality. We need to create the bins according to our functionality. Even if we create the bins according to our functionality, if those are not hit, then we need to modify the code. Okay, so this is the
Okay.
so this is the sequence of transitions. Okay, we are checking the sequence in bins. Before we have checked only one value, 1 to 1. Okay, clear? Clear? Next, third one. What is the third one? Set of transitions. Set of transitions means